Okay, we're going to be talking about Chapter 2, Section 3, and how to find the domain and the range. So our objectives on this video are how to find the domain and the range of a function. The solutions of an equation in two variables consist of a set of ordered pairs. A set of ordered pairs is called a relation. When a set of ordered pairs is such that no two different pairs share a common first coordinate, we have a function. The domain is the set of all first coordinates, and the range is the set of all second coordinates. So we're really talking about our x and our y here. X represents the domain, and y represents the range. Some other words that we use when we talk about x are input, y would be output, we can also say that x is the independent variable and y is the dependent variable. Sorry, misspelled that. Find the domain and the range of the function f, whose graph is shown below. And so basically this graph only has some coordinates on it. This coordinate is walk to -5, go up to 1, so -5, 1. This coordinate is 1, 0, because you don't go up or down, which is what they have listed here. We've got 3, -5, and then we've got 4, go up to 3. So the domain is the set of all the first coordinates, the ones that are in red, -5, 1, 3, and 4. The range is all the set of the second coordinates, 1, 0, -5, and 3. For the function f represented below, determine each of the following. The number in the range that is paired with -2 from the domain. That is, find f of -2. So this, whenever you see this, whatever's inside the parentheses is your x value. So they're saying when, so I'm going to write a over here. So f of -2 is saying when x is equal to -2, what is y? So if you go to -2, which is right here, and you go up to your graph, it looks like we would have a coordinate at -2, +3. So the answer to this would be 3. The domain of f. Okay, so what's the domain of our function? Well, when you're talking about domain, you're talking about what could x be. So always look at your graph from left to right. And if we're going from left to right, then this line right here, there's nothing on this graph that goes past this line. This is where it starts. But in fact, x could, because the dot is colored in, x could be equal to 5. So we would say our domain is from -5, and we've talked about this bracket already, which means it could be equal, all the way to right here. And what is x right here? 3. It can be equal to 3 because this dot is filled in. Now, so C says the number in the domain that are paired with 6 in the range. So what they want us to do is find f of x at 6. So remember that f of x is just a fancy way for saying y. And so that what this is asking is when y is 6, what is x? So we would look at 6, and if you draw a line through here, it looks like when y is 6, it looks like we're going to have to kind of estimate a little bit, but it looks like we're right at about 2.5. So f of 2.5, which is x, is equal to 6. Okay, and then it says, part D says, find the range. Well, the range is not talking about what x is, it's talking about what y is. And you always want to start at the bottom of your graph when you're looking for this. Start at the bottom of your graph and go up. Well, there's nothing happening. My graph is this little snake line right here, and there's nothing happening on my graph. In fact, the first time, if I go from the bottom up, the first time that anything happens on my graph is right here. What is y right there? -1. So my range is from -1. This is a bracket, not a parentheses, because it could be equal to -1. There is actually a value right there. And we would go up, 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 up until when? When's the last time I have something on my graph? It looks like y could be equal to 7 right here. So from -1 to 7 is going to be our range. Find the domain of f of x equals 2 over x minus 8. Okay, and remember, domain is talking about what can x be. Okay, now we ask, is there any number x for which 2 over x minus 8 cannot be computed? Since 2 over x minus 8 cannot be computed when x minus 8 equals 0, remember that you cannot, so you can't divide by 0. So that means x minus 8 cannot be equal to 0 because that would force us to divide by 0. So when you solve this, you would add 8 to both sides. So x cannot be equal to 8. It can be anything else, but it cannot be equal to 8 because if it is 8, 8 minus 8 forces this to be 0. And that's the one number that x is not allowed to be. It can be anything else. And so, thus, 8 is not in the domain of f, but all the other numbers are. And so that the way that they write this is x is all real numbers and x is not equal to 8. So, the domain of x is all real numbers and x is not 8. So this is the exception. It can be anything but 8. Let's go ahead and talk about Chapter 2, Section 5. We're supposed to find the y-intercept of a line from the equation y equals mx plus b, or f of x equals mx plus b. Remember that y and f of x, exact same things. Given 2 points on a line, find the slope. Given a linear equation, derive the equivalent slope-intercept equation and determine the slope in the y-intercept, and solve applied problems involving slope. A linear function, f, is any function that can be described by f of x equals mx plus b. So let's talk about this really quick. F of x is just a fancy way for saying y. M has a special name. It's called the slope, and that sometimes is referred to as rise over run. B is the y-intercept. In a graph, that's where it crosses the y-axis. So when they say graph f of x equals 3x, let's deal with that first. So f of x equals 3x. That's the same as saying y equals 3x. And if we write our y equals mx plus b, well, the plus b part of this would be our y-intercept, and there's nothing there, right? There's nothing written. It's not 3x plus anything. So on this line, our y-intercept, where x is equal to 0, is always going to be what your y-intercept is. Y is equal to 0. And so we know that is 0. So this one should actually cross at 0, 0, which is why this point is right here. The 3 tells us the slope. And when the 3 is just one number, you can put it over 1. So to get to the next point, you would go up 3 and over 1. So from the point we have, which is our y-intercept, we would go up 1, 2, 3, and over 1 to get to our next point. Which is going to be about right here. I think the line's off just a tad on the graph. Okay, so now remember that you can use your graphing calculator to graph and come up with a table. Really quick, let me transition over to the graphing calculator just so I can remind you how to do that. So if I wanted to look at the table of y equals 3x that was on our notes, I would go to my graphing calculator, I would hit my y equals button. We would want to clear this out. Okay, and so I went to y equals, which is right underneath the screen, the top left, and I want to hit 3x. And now I want to look at a table of that, so I would go second graph. That's going to give me my table. Remember on our table we had 0, 0, 1, 3, 2, 6. Okay, so this is a table of those values, and that's what I need to plot. So if we go back to our notes, okay, we can see that the same table that they had graphed, we've got 3 points and they plotted those points. Now, on the second equation, y equals 3x plus 2, now we want to look at y equals 3x plus 2. I'm going to write my y equals mx plus b over the top of that. Okay, so that means that the slope is still 3. But now look at this. We've got, instead of having plus 0 here, we've got 2. This is our y-intercept. So on my graph at 2, that's where it's crossing the y-intercept. If I go up 1, 2, 3, and over 1, we're at our next point using our slope, which is 3 over 1. I can also plug this into the graphing calculator, y equals 3x plus 2, and I can come up with my table. So I would have the point 0, 2, 1, 5, negative 1, negative 1. And so if you compare these two lines, basically we've taken the red line and we've shifted it up 2 spaces, which is why we're getting the plus 2 here. So the y-intercept of f of x equals mx plus b is, and we talked about this, is b is the y-intercept, and the way that you write that point is 0, comma b. So when you have the y-intercept, x is always equal to 0. It's where it crosses the y-axis. This is your y and this is your x. So the y-intercept is always where it crosses the y-axis. So for each equation, find the y-intercept. So y equals mx plus b. Well, the y-intercept would happen at positive 7. X is 0 there, so the coordinate would be 0, 7. F of x is a fancy way for saying y. This time, our y-intercept is negative, but the x-coordinate is always 0 there, so 0, negative 9 would be where it crosses the y-axis. So calculating the slope. The slope of a line containing points x1, y1, x2, y2 is given by the change. The vertical change over the horizontal change. The change in y over the change in x. Same thing. And we can write that as y2 minus y1 over x2 minus x1, or, now as long as you keep this consistent, these are both 2's, and these are both 1's. The y's on the top, x is on the bottom. Or you could switch it and have the 1's minus the 2's. We'll talk about what these little subscripts mean in a minute, but basically you're talking about 2 points. So one point would be x1, y1. The other point on the line would be x2, y2. Okay, that could be any 2 points on the line. This could be 2, 1. This could be negative 3, 4. Okay, it just represents those 2 points. So graph the line containing the points 3, negative 2, and 7, 5, and find the slope. So first thing we want to do is graph the point. So 3, negative 2, this point right here, and then 7, go to 7 up to 5, okay? So our formula says do y2, it doesn't matter which one you use. Most people do y2 minus y1. I don't know why, because to me it makes more sense to go the other way. But if we label our points like they have it, this is going to be my x2, y2, and this would be my x1, y1. It makes no difference if you had them reversed. It doesn't matter as long as you label them and keep it consistent. So they're saying take y2, right? y2, y2 is 5 minus, so we're subtracting y1, and y1 was negative 2. Now you got to be careful here because you're subtracting a negative number. On the bottom we've got x2 minus x1, so x2 is 7 minus x1, which is 3. So 7 minus 3 is 4. And so remember that a minus minus turns into a positive, so this is really 5 plus 2 on the top, which is 7. 7 minus 3 on the bottom, which is 4. Now on the graph, if we do rise over run to get from this point to this point, you would have to go up 1, 2, 3, 4, 5, 6, 7, and run 1, 2, 3, 4. So this is where they're getting their 7 and their 4. Go up 7 and over 4. If the 7 on the top is negative, you would end up going down and over 4. The slope of y equals mx plus b, the slope of the line y equals mx plus b is the m. We've already talked about that a little bit. The slope-intercept equation, y equals mx plus b, is called the slope-intercept equation because the slope is m and the y-intercept is b. It makes sense that that's what it's called because it's easy to find the slope and the y-intercept from the equation. So if we're asked to find the slope and the y-intercept here, The slope, remember, is m, and in this case, it's the number in front of x. In this case, it's 3/5, so we would go up 3 and over 5, and our y-intercept would be -4, this whole thing. And so remember that you want to always put 0, -4, because that's the coordinate, where that's the place where you would plot your point. So find the slope and the y-intercept. This one's a little bit different. You can't pick out the slope and the y-intercept from just looking at it this way, because we don't have y equals mx plus b. We have 4x minus 7y equals 2. So can we rearrange this so that we can see the slope and the y-intercept? Well, sure, right? We want to get everything away from y. This is one of the reasons we really worked on in chapter 1, moving the equations around. So 4x minus 4x is nothing. We would get -7y is 2, take away 4x. Then we would need to get rid of, if we wanted to say y equals, we need to get rid of the -7. So we would divide everything by -7. Okay, those are going to cancel out. Y equals, this is going to be -2 over 7. It doesn't matter if that negative goes with the top or the bottom. I like to put it with the top. And this one, we have a negative divided by a negative. Well, that's going to turn into a positive 4/7 times x. Now are we closer? This is what we have. Well, to me, this goes with this, and this goes with this, because this has an x behind it, correct? So that means that the slope is in front of the x here. We can still see that, it's 4/7. And our y-intercept is going to be 0, -2/7. Some applications use slope to measure the steepness. For example, numbers like 2%, 3%, 6% are often used to represent the grade of a road. A measure of a road's steepness, that is a 3% grade, means that for every horizontal distance of 100 feet, the road rises or drops 3 feet. Slope can also be considered as a rate of change. Okay, so they said find the slope of this treadmill. Okay, so remember that the definition of slope is rise over run, the change in y over the change in x. Well, look at this. The rise part is how tall it is. So we would want to put on the top the 0.42 feet, and on the bottom we would have 5.5 feet, because that's how much we would run. So the rise over the run. To get the percentage part, we would actually want to, remember that this fraction, this is really a division sign, so we would really want to do 0.42 divided by 5.5, and we would get 0.0763636, and this keeps repeating. But, so if we want to round that to, let's round it to the closest percent. Okay, and remember, to get a percent, you want to move your decimal places twice, so 0.0763 would end up, if we move our decimal place twice, it's going to move right here. So that is 7, and if we're doing their closest percent, then we would want to round up to 8%. Wanda's hair salon has a graph displaying the data from a recent day of work. A says, what can be determined from the graph? Okay, so when we're looking at this, X is the time of day and Y is the number of haircuts completed. So what we would be able to say is, so you always do Y over X. So since this is the number of haircuts completed, we would say the number of haircuts per, right, hour. Okay. What is the rate? Well, we would need to calculate rise over run. So they just picked out 2 points. You could pick out any 2 points as long as they go right through the middle. That wouldn't be a bad point to pick. Neither would this or this, but they picked these 2 on the end. So it looks like we go up. Okay, well, to get from 2 to 10, you're going to go up 8. Right, we're going from 2 to 10, so our rise would be 8. And then to get from 1 all the way to 5, that's going to be 4. Right, we're jumping from 1 to 5. It's going to be 4. So 8 divided by 4 is 2 haircuts every hour, right? Which is what they've come up with. And that's the end of those 2 sections in Chapter 2.